All right, let's talk about this paper, Scaling Up Visual and Vision Language Representation Learning with Noisy Text Supervision. And in short, it's called Align. So this is a funny paper because it's very similar to CLIP. It's basically the same overall idea. It came up in June 2021, whereas CLIP came up in February 2021. And this paper is from Google, whereas CLIP is from OpenAI. So it looks like basically these two groups had pretty much the same idea, and OpenAI managed to release it first and kind of scoop it. So Align is less well known. I think it's because it was less novel after it came out, but it's basically the same. But there are some interesting differences. But yeah, let's just cover the whole thing. So both of them trained their models from scratch, and both of them have this idea that they create large data sets of image text pairs, and they use contrastive learning to learn this embedding space in which images and texts that are related end up in the same place in this high dimensional embedding space. The details are a little bit different. So, for example, Align is using different models. They are using a BERT for text embedding and EfficientNet for the image embedding, whereas Clip used pretty much a plain transformer for text embedding and a vision transformer for image embeddings. But other than that, it's basically the same thing. One important difference is the dataset. So both have large datasets of image text pairs, but the dataset from Align is noisier and bigger. So OpenAI went through Wikipedia and WordNet and created queries of words that sort of commonly appear there, and then searched the internet for those things and learned and found the dataset this way. And they ended up with a dataset of about 400 million image text pairs. And it was somewhat high quality. Still comes from the internet, but it was kind of noisy. But they put in a bunch of effort to make it sort of less noisy. Whereas Align, this paper, they basically scraped the entire internet for image text pairs, where they basically take the text from the alt text of images on the internet. So any image you can add an alt text, and some of them are informative, some of them are noisy. So they did do some filtering to filter out instances where the text is obviously not informative or garbage or offensive and so on. And they followed similar methodology to some previous papers, but they applied less filtering. So they ended up with a very large data set, about 1 billion pairs. So it's quite noisy, but still good enough. And they argue that using this really big data set, even though it's noisy, allows them to learn, allows them to train a good model. But other than the dataset, the rest is very similar to CLIP. So I won't cover a lot of it. Standardly they do experiments, they do ablation study, they get pretty good results. The ablation study is kind of interesting. They evaluate different sizes of the embedding models and so on, and different pre-training data sets. One thing I do want to mention, because it's really fun, they also did analysis of learned embeddings. And that's not something that CLIP paper showed. It probably would do the same thing, but it's really nice to see here. So this is similar to the standard Word2Vec, the original work where they showed these linear relationships where they embed different words, and the word king has a relationship to the word queen that is the same relationship as between the word man and the word woman. So if you are in the embedding space, the position where the word man is, you apply the transformation, you end up at a woman. If you apply the same kind of transformation to the word king, you end up at the word queen. So that's kind of a nice property of the space. And here, Align, they show a very similar thing in image space. So, but the cool thing is that they have this common embedding space for both images and text. So they can take an image that represents some spot in this high dimensional space, and they can add or subtract words instead of images, because the words also can be represented in the same space. So if you take an image of a panda and add the word red, you end up with red panda. If you add the word Australia, you end up with a koala bear. If you add Madagascar, you end up with, I don't know, a gibbon or something. So this is really cool. So penguin in the forest, in the desert. Um, you can add different colors to the image of shoes, and you end up with the right shoes, and so on. So I really like this. Like this is really fun. It's really fun to see. I did not think of doing this, reading the clip paper, but I really like this idea. So I wanted to call this out. So this is pretty much it. If you understand Clip, you pretty much understand this work. It is funny to see that the social impact section here is like a quarter of a page, or not even that, whereas Clip had 3 or 4 pages, really intense look. But this is also overall a much shorter paper, so it's kind of more accessible, easier to read. Um, and I just wonder how, for example, if you took the clip architecture and trained it on this data set, would you get any better results? Or maybe the other way around. That would be kind of interesting to see. But other than that, this is everything. Thanks.